Good morning. Welcome to week 2 of Math 25. I forgot to record the warm-up problem. So briefly recap, then Janice has a $50 gift certificate. She wants to spend as much as she can, that when she boosts the cost of the meal by 25%, the gift certificate still covers it. And almost everyone asks, what is 25% of 50? And when you translate things and do some riplop, then you find that's $12.50. So let's take that away from the $50 and she can spend $37.50 on her meal. That looks completely reasonable. Almost everyone in the world does it this way, and it's wrong, because if we check what's 25% of $37.50, we have some extra money to spend. She doesn't quite use up her gift certificate. So the moral of the story is 25% of 50 and 25% of $37.50 are different amounts. A quarter of my income is a lot less than a quarter of Bill Gates's income. And we know this. We know that the same percentage of a bigger amount is bigger, the same percentage of a smaller amount is smaller. But the heads up, our brains don't always do this just because we know it. And here's the right way to do it if you want it. Okay, now let's keep going with new stuff. We ended by talking about parts of a gallon and things like that. We're talking about food preparation in the health decisions topic. And there's a small section about measuring spoons. So just like if you're not a culinary person, you might not know the parts of a gallon by heart, then measuring spoons, 3 teaspoons is a tablespoon, 16 tablespoons is a cup. And we don't do much with this, but since some people take Math 25 for the culinary program, I'm required to do a little bit. And so everything we do is open notes. You don't have to memorize this, but get used to those conversion rates also when you're doing the homework. If you like history, an interesting thing is Fanny Farmer. And there's a fun link here about someone writing about how she standardized the measuring spoon. She was part of the Boston Cooking School. And before her, when it said add a teaspoon to your recipe, you just took whatever little spoon you had and measured it. Your teaspoon and my teaspoon might be different, just like your cup and my cup might be different. But she was the one that standardized this and made cooking in the US, especially in the Northeast, much more of a science and not an art. So there we go. A little note that I will always use for teaspoon a lowercase ts, and for tablespoons an uppercase T and a B. Not everyone is as polite. Some people use TB or capital T, but not the B for tablespoon, which looks a little bit more like teaspoon. So I will use both distinctions to be clear. It's also true that 4 tablespoons is a quarter cup. That one you might actually use in the kitchen more. So these aren't terribly interesting. Try one at home. Ask me questions tomorrow. Not tomorrow, Thursday. I want to, maybe we'll come back and do one at the end if we have time. But I want to start with what's interesting and this thing about percent changes that we were doing our warm-up problem on. So if we have 100 pounds of avocados and peel them and pit them, we would find out we have about 79 pounds of stuff that's useful for cooking. So we need to figure out some way to connect the 100 and the 79. By the way, is my font big enough? Do you want me to make it bigger?
It's good.
It's good. And there's no right answer to this, except that someone has already made the decision for us. We could start from the point of view of the shopping. The 100 is sort of the original amount. And when we finish trimming, we get 79% that's usable. That makes sense. That's great. Nothing's wrong with it. We also could start from the point of view about what's usable. The trimmed amount is what we consider as the original. The recipe amount is what's original. Then we'd have to do the opposite of 79, which is 127%. We have to buy extra to have enough after we trim it. And that also makes sense. There's nothing wrong with that. So we just have to go with whatever the food industry has chosen, and they chose the first option and called it yield percent. So the original amount, oops, is how much we shop for, what we buy at the store. And then we do a percent to shrink it because we trim our vegetables. So we had that table that had the calories per minute per pound for people who were exercising. And I warned you that that table is useful in a math class to do homework, but it's kind of baloney, because if I ride my bike over Donald and Brian rides his bike along a calm, flat part of town, then that's very different. So this is the same. No two avocados are the same. No two chefs are the same. But we're just going to use these numbers for math problems because we are math people. And if you go to work in a professional kitchen, the software will have its own values, or maybe you would have a spot in the software to enter the value after you actually do it several times and see what your own yield percent is, and so on. But we just need some numbers to play with. Here are two more examples of tables of yield percents you can explore on your own. And we're skipping meats. It is also true that when you trim meats, you don't get as much as you started with. But that has so much variance that it doesn't even make sense to try and use it in a math class. We'll just learn how this works with vegetables, and we know that people trim meats, but we're ignoring that for now. So this is really easy as long as we keep in mind that lesson that we just learned from the gift certificate. If we have 100 pounds of potatoes, we know that potatoes have a yield percent of 78. I just have to ask the right question. In this case, I'm asking, what is 78% of 100? If you do a bunch of these, I'm doing too much work. You just know it's going to be 0.78 times 100. If you don't do a lot of these, then go ahead and translate it each time, because it doesn't take that long and you'll get the problem right. Since I'm lecturing, I am writing much more than you need to. And of course, we picked $100 for this example, so the math is trivial, but there we go. So what is 78% of 100? What becomes y is becomes equals. Take the percent, make it a decimal because our calculator likes that. Of becomes multiply, and solve for y. Everyone happy with the easiest possible way this happens?
Yes.
Yes.
Okay. So that doesn't actually happen much. That no one says, let's go buy 100 pounds of potatoes because I like round numbers. How much do we, whoops, I put dollars. Sorry.
I thought something was wrong there.
Well, say something when I make a mistake, because I'm thinking more about what I'm about to say than what I
Right.
say often. Okay, there we go. Oh, and I messed up over here too. That's not $100, that's 100 pounds. Okay, anyway, the point isn't my brain is broken. The point is that this doesn't happen. You don't buy 100 pounds of potatoes and then just see what happens.
Right.
So what happens much more often is this problem. Whoops, no, not a new window, a new screen. So this is much more realistic. We have the recipe needs a certain amount. So what are we going to do? We need to buy more than that so we have enough when we get back from the store. So what question am I asking this time? It's not what is 78% of 100 anymore.
Well, the question is how many pounds of potatoes we need to buy?
It is. Let me be more specific. All of these percent sentences I can write as blank is something percent of blank. So it's like Mad Libs. Blank is something percent of blank. So what do I put in my 3 spots?
Would it be 100 divided by
I don't want divided by it.
0.7?
Just fill in my Mad Libs thing to start with. You're jumping ahead.
Okay. Would it be 0.78 in the spot?
I'm going to just write it as 78%. It will indeed turn into a 0.78 soon, but again, you're jumping ahead.
Sorry.
That's okay. You can be impatient. Okay, what goes here?
Potatoes.
I want to say 100.
No, the 100 was over here. 100 is 78% of, I'll give you a hint.
Is it
You need a
22?
variable.
Why?
What? So our question is the 100 pounds we want is 78% of what bigger amount?
Ah,
And this is the hard part. Slow down, write your question correctly. Because as that warning happened, it's easy to do the math if you have the right question. If you put the wrong question, then it doesn't matter how good your math is. So 100 is 0.78 times y. I need to get y by itself. Let's divide both sides by 0.78 because that's the opposite of times 0.78. It's a funny place to write the y. Okay, so what do we get on that? So about 128 pounds. Everyone happy now that we see it?
Yep.
yes.
So just like before, if you did a whole bunch of these, I'm writing way too much. You would just know 100 times 0.78 is 78% of 100. If you do a whole bunch of these, you will know it's just 100 divided by 0.78 gets me my answer that's slightly bigger than 100. But if you haven't done a lot of them to build up that intuition, then write things out. It doesn't take that long. Okay, important stuff. So there's a general rule that when you multiply by something that's between 0 and 1, the number gets smaller. That's what we did first. We took a number, we multiplied it by something between 0 and 1, and our original amount shrunk. On the other hand, if we divide by something between 0 and 1, that gets bigger. That's what we did second. We took 100 and we divided by 0.78 and it got bigger. So this picture over here on the margin might help you. Oops. That when you divide by a less than 1 decimal, things get bigger. When you multiply by a less than 1 decimal, things get smaller. If that rule seems strange, it's because we're used to doubling and tripling and things with multiplying and dividing by things bigger than 1. but things less than 1 work the opposite way. Anyone need to stare at this more before I go down?
I can't afford it right now.
You what?
Never mind.
Okay. So we had that overture that we want to be able to go shopping for a recipe, and there were several steps. So we can actually do all this together now. Oh, and there's a typo there. That should be 2-track. So first we need to scale the recipe properly. If the cookbook says how to make 6 servings for a family and we want to make 100 servings for a restaurant, we need to change the size of the recipe. Second, sometimes we change units of measurement. If we had a small recipe that used teaspoons or tablespoons and we made it 100 times bigger, now we're using cups or gallons. Then we need to take the produce and adjust it the way we just did for the yield percent so that we don't run out when we trim it. And then finally, we have to turn the amounts of food into dollar amounts so we know how much we're spending. So these are the 4 steps we're going to use. So let me capture those. Oops. Then do an example problem. Okay. So some pretend recipe. It makes 28 servings and need 5 pounds of carrots. We want to make 105 servings instead. We want to figure out how much we're spending so we have the money for carrots. And we also want to steal that yield percent table because we will need that to know how many carrots to buy. I have no idea if I can fit this all on one slide or not. Ready to get started?
Yep.
Okay. So first I need to say how many pounds I need when I scale up the recipe. So this is so 28 servings went with 5 pounds. I could have written that upside down. It doesn't matter how I write my first rate, but whatever I do, I immediately stop and make sure that my words match. Remember we talked about this last time? If I have servings on top, it needs to stay on top. If I have pounds on bottom, it needs to stay on bottom. Whatever you wrote, make sure it matches. Then I keep reading. How many pounds of carrots does it take for 105 servings? So again, you can pick which diagonal to do. I will always do the one with the Y. It's not green. There we go. Whatever that is. 18.75. And it's not rounded after all. Everyone okay with part A?
Yeah.
So there was the shortcut. If you're not taking any math classes after this, you could just go 5 times 105 divided by 28 right away. We talked about the shortcut last time, but I'm going to do it this way, at least this first time, for the people that are going on to Math 60. Okay, part B. Do we need to change that? No, 18.75 pounds is fine. That's okay. You don't need to do anything there. For C, I'm going to scale up the 18.75 pounds. And partly because we just did one, and partly because I'm running out of space, I'm just going to divide by my 0.81 and assume that you know why I'm dividing by 0.81. If you want, I can take a new slide and write it all out again. And then finally, I would take my 23.2 pounds, multiply it by 75 cents per pound, and get about $17.36. Okay, yay, it all fit. Questions about any of that? That was a lot to do with one problem.
Where are you getting the money multiplier from?
It's right there in the problem. But yeah, the problem has to tell me. I'm not somehow magically in tune with the price of carrots. Does anyone want me to do step C the long way?
Yes.
Maybe I will next time. Let's see. So we have another one. Actually, I'm gonna again shrink this so it's not so wide before stealing it. This time I'll do the shortcut on the first part and not the second. Okay, ready for another one?
Yep.
Okay. Okay, so first we're going to make it bigger. Did I circle these little things? I did. Okay. So 16 servings goes with 3 pounds. So servings on top, pounds on bottom, pounds on bottom. How many pounds of celery should I make for 240 servings? So my shortcut was to multiply the two that have a diagonal and then divide by the odd one out. I don't want to write an equal sign here, sort of next step. So 240 times 3 divided by 16 gives me 45 pounds. Okay, step B. I'm okay with that. 45 pounds is a good way to go to the grocery store and try and buy celery. Step C, I'm going to ask 45 pounds is celery 69%. Of what? Translate everything. When I translate, there will be a riplop. Right into percent, left out of percent. Oops, pounds doesn't translate. Divide both sides by 0.69 to get y by itself. That is 65.2. And for my last step, I've kind of buried it, but $1.05 per pound. So 68.48, I think. Okay, questions about any of that one?
Nope.
Okay, so it's your turn to do one. So a reminder as before that you can use this Jam1 link to look at the Jamboard as I'm writing. So if you want to keep looking at what I'm writing when I'm not myself looking at it on my screen, you can do that. Well, let's go to a random problem. And, oops, not calories, food preparation. So try and do 1 and 2 together. That big enough, or do I need to? That looks too small for me. One moment. I will fix that. See people squinting. Oh, okay. Try that. If you get an answer, put it in chat so that everyone else can see. Work on it together a little bit, and then I'll do it at the end. And if you want to see my previous slide, that's why I showed you the Jamboard link, so that you can look at my notes as well as your notes. Okay, let's make sure you're doing this and not just playing Overwatch while your camera's off. So share in chat your beginning of part one. How many pounds do we need just by scaling the recipe?
I'm struggling with it just a bit.
Okay. With this first step
You
or
and
a
Steve.
later step?
The first step.
Okay. So we're making our proportion. Did you put servings or pounds on top?
First time I did servings, second time I did pound.
Well, that would be why. So it has to match. If servings is on top the first time, it has to be on top the next time. So in one situation, we have 33 servings make 6 pounds. In the other situation, we have, I have no idea how many pounds, for 257 servings for feeding an army. Now that we got
Okay.
it set up, should we use the shortcut or the longer way?
Longer way.
Longer way, okay. So I will y times 33 6 times 257 whatever that is. Opposite of times 33 is divided by 33.
Okay, that makes a lot more sense.
Okay, glad it helped. Our next step is, do we need to change the pounds to anything? No. This is usually, again, if you start with teaspoons or tablespoons, and now you're going to use a more realistic scoop. So third step is it's produce, so we have to buy extra. So we're going to scale for yield percent. So we say 46.7 pounds is, and it tells us yield percent of 66%. Do I need to keep writing the riplop, or are we done with that? No answer. Okay, I will keep writing the riplop. Left out of percent. There we go. Okay, the opposite of times 0.66 is divided by 0.66. I'm getting about 70.8. Then finally, I find the cost. Oops. So we take the 70.8 pounds, multiply them by 60 cents per pound. And $42.48. If your answer is off by a few cents, that's fine. If you've been watching in the little webcam as well as on the screen, you'll notice that when I get to an answer, I don't clear my calculator. So I'm writing on the screen 46.7, but what's in my calculator has a lot more decimal points. And so when I take that and divide it by 0.66, I'm not losing any accuracy because I'm rounding in the middle. And similarly, I'm writing 70.8 because that fits on the page, but my calculator had more decimal points there. So when I multiply by 0.6, I'm not losing any accuracy. So if you get $42 and something else a few cents off, that's fine. I would have also if I had actually used these numbers that I'm writing instead of the version with more decimal points. No one cares about a few cents. It's all going to come out. Should we have you do another one?
Yes.
Yes. Okay.
Yeah.
Randomly generate another one. So again, if looking at my thing is great, open up the Jamboard yourself so you can look at my notes as well as yours as you're trying this one. Now that I know how it will fit on the page. Just might- Should I talk more about the word scale? Is everyone happy with me using it twice?
Can you explain that? Okay. Scaling went back to, again, this picture. A scale factor is when you are taking a measured amount and making it bigger or smaller for some reason, and everything else has to change in a proportional way. So when we're zooming in and out on a photocopier, when you're zooming in and out with your camera, when there's shadows that are a certain size compared to the original object, those are all scaling, when everything changes in the consistent manner. I see Timothy does a thumbs up on Zoom. Thank you. I still think that Kate and KJ and Brian are playing Overwatch, but that's okay. Now he unmutes. Okay. Should I start this first box, the scale for recipe size?
Yeah.
Okay, we're ready for that. Is it okay if I put servings on top? Everyone is used to that by now. I shouldn't change it on you.
That's
So
fine.
35 servings and 9 pounds. If you do flip it, that's fine. Just be consistent. Whatever is on top stays on top. Very important. Whatever is on the bottom stays on the bottom. So we want to make 266 servings, and we're not sure how many pounds.
as always, a reminder, I am writing more than you need to because I am lecturing. Not only is there a shortcut you can use if this is your last math class, but the 2 lines I am writing now are not both necessary, as we talked about last time. If you were to leave off completely this line, that's fine. I could still say y times 35 is this thing. We're dividing both sides by 35. I can follow what you're doing. If you were to leave out completely that line, that's fine. I could still say, oh, to get from here to here, you must have divided both sides by 35. So you don't need to write as much as me. But if you're going into Math 60 or something, this is hugely important. Write that line. Okay, should I do the next box? Or do you want more time to do it yourself?
We can go ahead. I'm okay.
So 68.4 pounds. 74%. The yield percent they give it to me. The opposite of times, 0.74 is divided by 0.74. And 92 point. I boxed that last time I did. Okay. So 67 cents per pound. Gives me 61.93. Oh, questions about any of that?
No.
Okay. So this is not hard, it's just a lot of steps. So just like some of the stuff we did last time, then people miss points because they either didn't practice enough or just because they make some silly calculator mistake. So practice for both reasons, that you learn when to divide and when to multiply, and that you get some sense of noticing, oh, if this was 192, I must have hit something wrong on my calculator. Okay, moving on. If we had the Factfulness book, I would have given you another interlude, but we don't. And let's talk about writing math notes. So why is that so slow? Come on, internet. Okay, well, we'll do that once it loads. So we've now finished health decisions. So that was really fast, only 3 classes, and we've gone through our first topic, Again, this is sort of the straightforward topic, but that doesn't mean we're done with it. If we do nothing at all on Thursday other than review these kinds of problems, that's great. We don't have to rush on to the next topic. So we started with patterns. Patterns homework, by the way, everyone hates. It's always the hardest homework in the entire class. I tried to make it nicer this term than last term, but if you hate it, oh well, I'm sorry. I'll try and do better. Then we had calories. We talked about exercising and we talked about calories in the food. We did heart rate and BMR and DCI formulas. And then we had all the stuff we just did about scaling. The only thing we didn't do yet was the teaspoons and tablespoons. So this for some reason isn't going. Jump back down there and do that. Not paste. There we go. Okay, a restaurant recipe that makes 30 servings requires 2 cups of butter. You want to use this at home and make only 6 servings. So maybe you can just look at this and say we're dividing by 5. Let's pretend that doesn't happen. So 30 servings, you did 2 cups of butter. So 6 servings needs who knows how many cups. Who am I multiplying? The opposite of times 30 is going to be divided by 30. So I get 0.4. Now my math is correct, but saying you have 0.4 a cup of butter is kind of awkward. So we know that there's 16 tablespoons in a cup. Excuse me. So this is 0.4 of a cup. That's going to be 0.4 times 16 tablespoons. And at that point, it's sort of up to you and how much you like butter. Do you want to round this up to 7? Do you want to round it down to 6? That's personal preference. You are the chef. The point isn't whether the answer should be 6 or 7 to make your recipe the happiest. The point is that this answer is really awkward. For home cooking, this is the same amount, 6 or 7 tablespoons, but looks much better. What did I do? I substituted. Where there was a cup, I knew that a cup is 16 tablespoons, so I just put the 16 tablespoons and multiplied that by the 0.4. Should we do another, or is one enough?
We could do another.
Another? Okay. Silly page. Sorry, my internet is being slow. Well, maybe I can just start. So convert 0.2 cups into tablespoons. So if I have 0.2 cups, I'm going to do the same thing. That wherever I have cup, I can also write 16 tablespoons. If you're wondering, why am I multiplying? That's because multiplying goes with the word of. So this is 0.2 of a cup, 2/10 of a cup. So since I'm saying of, that's why I'm multiplying. That's not the friendliest thing in the kitchen. Again, it's up to you based on your recipe, and you are the chef. Should I round this down to 3? Probably. Maybe you want to round it up to 4 if you really like whatever ingredient this is. The last kind of one has a mix happening. Oh, that one does go. This is suddenly working. That. There we go. Okay, so this one, they're trying to trick us. Express 3.2 cups as 3 cups and some tablespoons. So the 3 cups can just hang out and be fine. It's only the 0.2 cups that I need to worry about. I'm going to say that 0.2 cups. What's my next step? Doing this just like before.
Timesing by the 16.
I'm multiplying it by the 16 tablespoons. Right, 0.2 cups turns into about 3 tablespoons. Then I put things back together. I have the 3 cups and I have 3 tablespoons. These 3 cups didn't go anywhere. All we did was play with the 0.2 to make it into tablespoons. Sometimes that's confusing if I don't explain it great. Is everyone okay with how the 3 for the 3 cups just sort of hangs out up front?
Yeah.
And the fraction amount is what we're really trying to change into tablespoons, or the decimal amount.
Yes.
Not sure why that's not loading still. Oh, okay, well, we'll do what we can. Let's see what the random problems say. One thing it might ask you to do on a test is another proportion. This proportion is in the homework to try and trick you. So let's talk about what it's doing tricky. I start by reading 1 gallon is 8.5 pounds. So 1 gallon. So what I want to do is put gallons here and pounds here. Because if it says gallons on the top, it has to stay that way. If it says pounds on the bottom, it has to stay that way. However, when I read it, what's the weight? Okay, so far so good. Of 18 cups of eggs, I don't have cups here. So if I want to put cups here, I have to switch it here also. So I'm going to take away this and say the gallons was a red herring, a distraction. This should be 18 cups. And then this one has to be cups. So how do I take 1 gallon and make it into cups? Who remembers from last time?
Something about
Remember that picture? Okay, so cups in a gallon, how many? 16. So I had to change my thing. This used to be 1 gallon, but instead I have to rewrite it as 16 cups. And that's how they're trying to trick us. But now I'm good because it matches on top, it matches on bottom, my words are all happy. So I get y times 16 is 8.5 times 18 what is that? 8.5 times 1,853. The opposite of times 16 is divided by 16 to get the y by itself. And I get about 9.6 pounds. I'm rounding to 1 decimal place, following that general rule of keep the same number of decimal places they give you, or maybe one more. So if you wanted to do 9.56, that could be fine too. Okay, next homework problem. Anyone need this one with more time? No, okay. So, So this is like the other one we did before, where we kept the whole number, it just hung out. Well, we took the decimal part and changed it. So you try that one for a moment, and I will do it. I'm going to mute myself for a moment just because I want to check in on my kids. I hear something happen. It's 11:27. We're going to run out of time. I'm just going to do this one. Otherwise, I'm going to be asking you to stay late, and that's rude. Okay, hopefully you could have done that yourself. So real quick finish up, since it's 11:30. Your job is to go over all of health decisions. So patterns is kind of officially due today. Still turn it in if you're late, that's okay. Calories and metabolism will be due next class because we had no questions on them at the start. And food prep, it has no due date yet, but we're done. So you can start that one if you have time. I know it's only 2 days. But bring back questions for these because I want to spend more time in health decisions until everyone is very comfortable with it. I don't want to rush ahead into the next topic. Any other questions or things before we're done?
Just to make sure I heard you right. Calories and food prep will both be due?
Now, calories and metabolism,
Okay, cool.
because those are the ones that we had finished before. And at the start of class today, I said, anyone have questions? And you didn't. So that makes me think we're ready to turn in homework.
Cool, thank you.
David,
Food
what
prep
time
has
is
no
your
due date
study
yet.
session? What time's your study session tomorrow?
What time is my study session? I think it is 2 o'clock today. Let me double check. Can I get to my own calendar? Yeah, 2 o'clock today for a study session.
If I wanted to do some time on patterns with you, what would be a good to do that?
That would be a good time.
Okay, so today at 2.
Yeah, today at 2. If today at 2 doesn't work for you, let me know and I will do a different time. But if that works for you, then that's good.
Okay, I'll try to make that one.
I also know that there are a number of people that still need to work on patterns. They turned in something but didn't get 8 out of 10 yet. So I don't think it's only Donna that wants to be here and work on patterns together.
Yeah, okay, I will see you at 2.
Okay. Either see you in a bit at 2 o'clock or have a good couple days.
Thank you, David.
Thank you.